Hello YouTube, this is Jay Coder back with another video, and today we're going to be going over some interesting tips that I think will help you guys out when programming in Jetpack Compose. I have about 3 videos I want to go over with you guys, just so that you guys can have the tools and tips and tricks that you need to be successful programming with Jetpack Compose on a UI for Android. So without further ado, I'm going to go ahead and get started. I may or may not comment during the video, but yeah, I'm gonna just leave that as a discretion there. So alright, I'm gonna go ahead and I'm gonna mute the music here. And so alright, the first video I want to go over with you guys is Compose tooling, and this guy is gonna show you some pretty neat tricks that you can do with Jetpack Compose. So without further ado, let's go ahead and get started with this video. And also, if you're new to this channel, please subscribe. All right.
Compose allows you to build beautiful UIs quickly. But together with the Android Studio tooling support, you're able to accelerate the development process even further with faster iteration and better debugging. Previously, we implemented a single answer option in the Jet Survey app. Let's see how Android Studio can help us write this efficiently. Let's go ahead and open the Jet Survey project in Android Studio and see what features it has in store for us. To start writing our composable, simply write COMP and press Tab or Return to automatically generate the composable. Let's call it Survey Answer. Hit Return and start implementing it. To implement the row inside our survey answer, we simply type WR and press Tab or Return to generate the row. Similarly, if you want to wrap a component around a row or another layout, you can right-click the component, select Show Context Actions, Surround with Widget, and then Surround with Row. These shortcuts are called live templates that help you generate common code snippets. Check all of them in your Android Studio preferences under Live Templates. Next, we can implement the content of our row. We start by adding an image that displays the lens drawable. We'll use the Painter Resource API to help load this. One of the challenges when working with drawables is that it's hard to know what the drawable looks like. But as you can see, the image shows an icon in our editor's gutter. This makes it easy to quickly preview and switch to another image. Let's go ahead and switch the image to display Spark. Next, we implement the row's text, and let's give it a custom color. You can see the color showing up in the gutter. Clicking it gives us a color picker that we can use to quickly change the color. Here you can enter RGB, hex, or easily pick colors out of the material color palette, which is quick and handy. Finally, we implement the radio button. Live templates and gutter icons help us write code while making fewer mistakes. Now, let's see how we can quickly iterate on our UI using previews. With our basic composable function, it's time to see how this composable actually looks. It would be great to be able to see our composable while we work on it, without having to run the whole app on a device. This is made easy by creating a preview composable. Simply type prev and press Tab or Return. This generates a composable function with the extra @preview annotation. Let's call it Survey Answer Preview and tell it to render our Survey Answer composable. Something to keep in mind is that composable functions annotated with the @preview annotation cannot accept arguments, so we must provide all the data needed to preview a composable. Let's also wrap this in our app custom theme. The preview annotation tells Android Studio that this composable should be shown in the design view of this file. So when we click the split icon at the top, and we press build and refresh, our composable preview shows up. Using the cogwheel in the gutter, we can specify all kinds of properties of this preview. For example, you can show the preview with a certain background color using night mode. You can add the preview annotation to the same function multiple times, so we could also choose to add another preview that shows the form item with an extra large font. Closing this pop-up should then reflect all the changes that we made into our code. Oftentimes, you want to see how your composables look like in different configurations, in light or dark mode, in different font sizes, and so on. With the multi-preview feature in Android Studio, you can define an annotation class that itself has multiple preview annotations associated with it. Let's take a look. To make a multi-preview annotation in a file, define a custom annotation class with the desired preview configurations. Here we're adding a small font and large font version. You can also add another annotation for displaying both dark and light mode. Then, simply add that custom annotation to your preview composable, and the different previews will be shown automatically. If you want to see how this preview behaves on an emulator or physical device, we can use the run icon in the gutter. Instead of following the preview's configuration parameters, this will use the configuration of your device. When you update a composable, you have to build and refresh the preview or redeploy to your device. With live edit of literals, rebuilding isn't necessary for certain constant literals like integers, strings, and colors. For example, if we update the name of our superhero, we see that changes being updated immediately. Similarly, we can change the color of the text without needing to rebuild. Live edit takes this behavior even further and lets you adapt the contents of a composable function without needing to rebuild. Working on our form item, we can add modifiers, properties, or even remove or add child composables. All these changes are automatically reflected on your device. Live edit is a new experimental feature, so right now it's not available by default. Read the documentation to learn how you can enable it for your project. With previews, multi-preview, live edit of literals, and live edit, iterating on your design is a breeze. But what if there's something wrong with your composable and you need to debug it? Android Studio allows you to dig deeper so you can figure out what's wrong. First, let's open up our layout inspector. We have to select the process we're interested in, so let's select the JetSurvey app running in our emulator. It shows us the current screen of the app. On the left is a component tree that contains all the nodes in our UI hierarchy. We can expand all of them at once and we can see what our composables look like. This tree can get quite big, so we can right-click on any node in the tree and show only its parents or its subtree to simplify our view. On the right, we see the attributes for each of the composables in our node. For Lambda attributes, we can also see a link to the specific line in code where the Lambda is defined, which helps a lot when debugging. While implementing a design, we can overlay a picture on top of the layout, which helps to verify if our design implementation is pixel perfect. In our case, we can see that there's still some more work to be done. From the previous episode, you know that using components from the Compose toolkit will give us that pixel perfection. I'll leave that as an exercise for you to do. And that's it. That covers a lot of the helpful tooling provided by Android Studio to help us develop apps much faster in Compose. To summarize, with live templates, we can insert common code snippets much faster using abbreviations. Contextual gutter icons allow us to quickly change things like images and colors. The add preview annotation allows us to see our composables without having to deploy the entire app to a device. Both the live edit of literals and live edit allows us to see code updates in real time. If you've been following everything so far, congratulations. I hope these episodes have helped you get started with Compose. Coming up next, we have a tip from a community member on how you can speed up your learning with Compose. After that, we'll wrap up with a live Q&A with me and my teammates. You can tweet us your questions by using the #MadCompose hashtag. As always, like and subscribe for more, and I'll see you soon.
Alright guys, so that was the first video I wanted to show you. Hopefully you learned something interesting about those tools that he shared with us. And this next video I think is kind of an important overview that we can take a look at for converting, for migrating from the views to the compose, because that's what a lot of Android developers are doing, because there's a great transition right now to being able to have apps mostly be developed, the UI being developed with Compose. So let's go ahead and check this video out, and yep.
Have you already learned the benefits of Jetpack Compose but aren't sure where to get started with converting your view-based app to Compose? I'm Chris Ariola, a developer relations engineer on the Android team, and in this talk, I'll answer that question by showing you how you can migrate. So, you have an existing view-based app and you want to convert it to Compose. But of course, you don't want to stop building new features just to make this migration. The good news is Compose was designed with view interoperability right from the start. So you can make this migration while still adding new features to your app. Here's an overview of the strategy that you can take. First, start your adoption of Compose by building new features in Compose. This way, the features you build take advantage of the benefits of Compose. While building features in Compose, you want to identify which components can be reused in other parts of your app, and then start building a library of common UI elements. And lastly, continue your migration by replacing existing screens to Compose one screen at a time. These steps don't necessarily have to happen in sequence. Depending on your team size and your app size, these can all happen in parallel. So let's dive into the first step, which is to adopt Compose and new features you introduce in your app. This approach to migrating allows you to modernize your app while still addressing business needs by being able to add new features. If your feature takes up an entire screen, you would still be working under the constraints of your app's architecture. So if you're using fragments, you would create a new fragment with its contents in Compose. And if the entire screen is in Compose, you would return a Compose view in the fragments on create view lifecycle method. And then you would provide the fragments composable in the set content method of the Compose view. If the new feature you're adding is part of an existing screen, on the other hand, you would add a Compose view to the view hierarchy just like any other view. And if you have multiple Compose views in the hierarchy, you want to make sure that you have unique IDs so state is preserved across configuration changes. So as you're building new features, you'll probably realize you're reusing a lot of components. So to encourage reusability, consider creating a module of common UI components in your app. This would be a great opportunity to work with a designer in your team to help identify what those components are. Think buttons, app bars, chips, and so on. This technique is especially useful if you're building a custom design system for your app. Try to also find complex UI components that can be reused, like dialogues, cards, and so on. The features you build can then depend on this component library, which allows you to style and change the look and feel of your app's components all in one place. The last stage in your migration is to incrementally migrate existing features one screen at a time. Note that it's also best practice to rely on UI testing while migrating existing screens to ensure you're not introducing regressions during migration. So how do you go about migrating existing screens? A good place to start is to try to find simple screens. These are low-hanging fruit, as migrating these screens can be done in a few lines of code in Compose. The next place to look for are mixed screens, so screens that contain a bit of Compose code already. For these screens, you can take the bottom-up approach of migration by piece migrating UI elements until the entire UI tree is in Compose. Keep repeating this process until all your screens are in Compose. Assuming you're using navigation component and all your screens are in Compose, what should you do about fragments? Once all your fragments' contents are in Compose, there's really little benefit that fragments give you at that point. So, at that point, once all the contents are in Compose, you can remove fragments entirely and replace them with a corresponding screen-level composable. You can then use Navigation Compose to navigate and pass data between these screen-level composables. If you're ready to get started with migrating to Compose, make sure to check out our documentation, Adopting Compose in Your App, to learn more about implementation details. And if you want to learn more about case studies on different strategies that work for other teams, check out our Adopt Compose for your teams page at this link. Now, you should know where to start. Thank you.
All right, guys, so that was a pretty good overview, high-level overview of what to do with converting to Compose. There's usually, with these tutorials, they, it's sometimes hard to see the big picture, and how would you do this in like a production environment, things like that. And so this particular video was a very good video to help us to be able to transfer to Compose, where we're not, making a Compose app from scratch, but what do we do if we have like an existing code base, and how does that structure work? How do we introduce Compose into an existing app? And things can just become more complicated than just a simple hello world application using Compose. So I like how they released this video here to have you have like a high level overview of how to handle structuring the app with Compose, especially with an existing code base. All right, and so there was another final video that I wanted to go over for today for us, and this is going to be going over animations in Compose. And this is basically something that will help your apps look better and more flashy instead of boring and static. So let's go ahead and go over this.
Hi everyone, my name is Rebecca Franks and I'm an engineer on the developer relations team. Does your app look super static and you want to learn how to make it super fancy, super fast in Compose? Let's learn how to add some movement to our apps in a few minutes. Okay, let's go. If you're hiding and showing content on screen, just like we are doing here in the JetChat app, you can see that the timestamp is visible and invisible on click. You might not like how jarring this looks to your users. Instant changes in UI states are painful to experience, so let's make this better. Taking a look at how the text is shown on screen, we can see that it is using just a simple if statement to show or hide the timestamp. All we need to do to improve this is to wrap our changing visible state in an animated visibility composable, and this will magically transform how state changes are shown on screen. Let's take a look. That looks way better, don't you agree? Animated visibility also has a range of different customization options that I recommend reading about in the docs. Next up, this Now in Android screen is showing more text on click of the item card. But the size change looks very static and doesn't transition smoothly between the two states. Taking a look at the code that powers this, we can see that we toggle the expanded state on click of the text by changing the max lines that will be drawn on screen. We can easily fix this jumping state with a built-in modifier. simply add animate content size to your modifier chain to get an instantly smooth change. And this looks a lot better already. The change in sizes is way smoother. But what if we wanted it to be a little bit more playful, maybe with a little bit more bounce? Having a look at the code again, we can change the animate content size modifier to take in an animation spec. Most animation APIs offer the ability to set an animation spec that we can use to define how the animation happens. In this case, if we are using a spring spec and setting the stiffness to low and adding slight amounts of bounce, we can see that our UI will now look a little bit more playful with this added bounce. Ready for another one? In Crane, the content underneath the Fly, Sleep, and Eat tabs is switching between completely different composables without any smooth transitions between the content. These changes could definitely do with a little bit more magic. Taking a look at the code that decides what section to show in the purple area, we can see that there is a conditional used to determine which composable to display in that section. Using a when with different composables is a sign that you can probably use animated content to animate between these different composables. So let's wrap this conditional in animated content composable, providing the target state that will be transitioned to. Using the target state inside the animated content composable, we can then switch our content based on that target type. Instantly, our transitions between the different composables is now fading and scaling between each other, which looks a lot better than before. But we can make this even more interesting. Okay, so back to the code. By changing the transition spec on animated content, we can customize how the new composable coming on screen will enter the screen, and how the old composable will exit the screen. In this example, we are using slide into container to slide the content towards an upward direction, and slide out of the container in a downwards direction. We have also customized the animation spec to set a custom duration and easing function. So let's take another look at what this looks like. How does that look? Our new content slides in from the bottom of the screen, and the old composable slides out from the bottom. Of course, this is customizable. Check out the different enter and exit transitions available to you in the docs. Alright, on to our next animation example. We have the progress bar in the Jet Survey app. And when you navigate between the different pages of your app, the progress bar shows your progress remaining of the whole survey. At the moment though, this looks pretty bland. Taking a look at the code, we can see that the progress calculation is using state information to determine how far along in the survey you are. In this example, as a user progresses along the survey, the question index will increase. We can switch this variable to use one of the animate as state functions. In this case, we are using animate float as state. These functions automatically perform the animation when the state of your input variable changes. So by passing this animated progress to our linear progress indicator, we will see the progress animates between the first state it was passed and the second state that it is using. It is worth noting that we've used the value on a specific composable parameter, but we could also use the animated progress to change a value anywhere in the composable, such as a modifier's parameters. So let's take a look at the small change in action. Now the progress bar animates between the different survey pages and looks much neater. Now say we wanted to animate something repeatedly, like this custom rainbow border. We would like the colors to rotate around the outline of the image. In order to draw this, we have an image composable with modifier.drawBehind that draws the rainbow gradient brush. This circle is what we will be animating. Now to animate the changes, first we create an infinite transition using remember infinite transition, and we define a single float rotation animation that we want to animate from 0 to 360 degrees. We supply it with an infinite repeatable animation spec that is going to animate between these two values in 1000 milliseconds. So we've defined all the variables, but we aren't using the rotation animation variable anywhere. All we need to do to animate this now is to use the rotation animation value and call rotate in our drawBehind function. This will rotate everything that we are drawing on screen. Compose takes care of updating the rotation animation variable for us and will automatically trigger a redraw as the variables change over time, creating the animation on screen. Now take a look at that rotating rainbow gradient. Adding a simple rotation animation makes the profile pic stand out way more. And that's it. Hopefully you've seen how quickly you can add animations to your Compose apps. For more information on animations in Compose, check out the following links. Right then, I'm off to go move some more pixels around on a screen. See ya!
Alright, so those are the 3 videos I wanted to show you guys for today. And so, yeah, I hope you guys learned something about Jetpack Compose, and I hope you guys liked my Jetpack Compose series. I'm sure you can be able to learn a lot from the previous videos on Jetpack Compose. And so, yeah, so go ahead and subscribe to this channel, and I appreciate you guys watching this video, and as always, stay coding. Alright,